So good afternoon everyone, welcome to this Graitec Advanced Steel webinar where we're going to be looking at modelling secondary steelwork within advanced steel and the tips and tricks, and then what we can achieve with the Graitec Power Pack and Stairs and Railings BIM designer. So a little bit about me, my name's Rob Merriman. I've been working in the construction industry since I left university. Spent 8 years as an architectural metalwork and structural steel draftsman using advanced steel. I currently work for Graitec UK as an application engineer. My main focus is advanced steel, but I now look at all software within the AEC collection. So if you do have any questions on anything at all, please just reach out to me. Today's presentation has been printed off as a PDF, so you've got all our contact details and everything. The links are embedded within the PDF. So just before we get going on this webinar, we have recently released our Advanced Steel content portal on our website. So all our previous webinar recordings, all our blogs and our tips and tricks can now be found on this dedicated Advanced Steel content portal. So if you don't catch them on the day that they're going out live, they will be uploaded onto this portal so you can catch up whenever. With our blogs, if you haven't subscribed, if you click on the embedded link, that will take you to our blog page and you can subscribe to the Advanced Steel blog. So every time a new blog comes out, it will go straight to your inbox. And for future webinars, we'll let you know on technical support. If you keep an eye on my LinkedIn, every time we announce a set of webinars, we'll put it there. There is also a link to our Graitec events page where all of our events, not just the Advanced Steel webinars, all the webinars, all the events we have coming up are all on that page. So today we're going to look at some steelwork modelling tips and tricks. We're going to look at beam from line, split beam commands. We're going to look at the Propagate joint in 2020. Then we'll look at what we can do with the Power Pack, with the cover tools, and then finally we'll give you a little idea of what can be done with the Stairs and Railings BIM designer. So we'll start with the just advanced steel modeling tips and tricks. We're going to look at using the beam from line command to model direct from client's drawings. We're also going to look at the split beam command, which will allow you to split the beams up into the lengths as you require them. And then for 2020, there's a new feature that's been released called Propagate Joint. So that allows us to populate the model with joints very quickly. So we're going to start a new template. So I'm going to start a brand new template, and what we're going to do, first thing we're going to do is save the file, because we don't want to be working in just drawing one. We don't want to do a morning's worth of work and then something crashes or something goes wrong and we lose a morning's work. So first thing I always do when starting a new project is to make sure I save the project, and then I'm going to put the project data in, the project information. So we're just going to put the project number, the client. Closed it down a bit too soon. And then we're going to put the designer and the detailer in. So this project, we've been given an engineer's drawing, so we want to use this drawing. So what we're going to do first of all is we're going to freeze all the layers apart from the two that we select. So that will turn off all the layers apart from the grids and the column positions. And then I'm going to copy those items into my model. You should never model in an engineer's drawing. You always want to work in your advanced steel template. So we're going to bring those items into the template file. Then I'm going to create my advanced steel grids over the top of the engineer's grid structure. So I want to use advanced steel grids because they'll show up automatically on the drawings. It will give me node points automatically. So I'm just doing grids with groups by distance, setting the direction, and then I'm typing in the distances between the grid lines. So that will put the distances in between the grids. So that's my grids in one direction. So we'll just put a balloon around those. And then once we have grids in one direction, we're going to use the node points of those grids to create the grids in the opposite direction. And again, we just need to then type in the distances between the grid lines. So we're going to set up a couple of levels. So I have done a previous webinar on the whole Project Explorer. I'm going to put a level 1 in, and then, sorry, a level 0, and then a level 1, which is my top of steel level. So again, this is just all stuff that I can set up beforehand, just makes modeling a lot easier. Now I'm going to put the columns in. So what I'm going to do is the columns now, because I've got these work planes between level 0 and level 1 activated, the columns will go to that length. And what I'm doing, I've got node on. There is actually a node point on my engineer's drawing, so just hover over the column positions, and those columns will be at the correct height because we've got the work planes activated. So we can change the section size of those columns, make sure we've got the positioning set, then what we're going to do, we're going to turn off all the advanced steel objects because I don't need these grids anymore, any of this engineer's information, because I've got the grid structure that I need. So I'm just keeping my model nice and tidy and removing things from the engineer's drawing. So now what I'm going to do, turn all the layers on. This time I only want to bring the engineer's floor level of steel. So rather than the beam centers and the grid, I actually want to copy out from a node point of a column the actual mezzanine or the level of steel. So then I'm just going to paste those in using the node point on the column. So I've then got my floor of steel. We're just going to turn off a few of these level markers. So again, I'm not redrawing anything, I'm just using what the engineer has given me. So I have these lines. I'm going to select one. I'm going to use right click and choose select similar. That will pick up all of the lines in the model. I'm then deselecting a few because I've got different section sizes. So I'm picking all the lines I want. Then I'm going to use the beam from line command. So the beam from line command in there. Do I want to delete the lines afterwards? So I'm going to say no. That will then create beams on top of the engineer's lines. So we can set the section size. We're going to set the positioning. And we also, before we go any further, want to make sure we set the model roll. Then we're going to repeat that beam from line command for the remaining beams that are in the model. Again, we choose no on the deleted object. That will remember the section size that I put in last time, so we're just going to change the section class to I sections, and we'll just change the beams to the correct beam size. Again, make sure your system line position and your model roll is set before you go any further. So the more you do as you're going along, the less you will have to do at the end. I did do a webinar earlier on today on checking your advanced steel model. That is in our content center. So the reason the system is remembering this is you can right click at the top of any menu and you can tell it what to remember. So it won't remember the model roles, but now I've ticked it, the next time I go to draw a beam element, it will remember the model role that I set last time. So these beams in here are all too long, so we want to split the beams up. So there is a split beam command. So I'm just using the engineer's lengths, and I'm saying, right, I want to split these 3 beams at the node point at those 2 beams there. So you can choose multiple beams at once, and that will then split them up into the lengths that we need. And the same with these beams, is we want them split up at these points. And we're just going to repeat it for the last one. So I'm using my node point, so I don't have to draw, even though my engineer's got his line full length, we can then use Advanced Steel tips and tricks to split those up. So now we're going to put the connections on. So I'm putting my base plate on. I'm going to name the joint because it's my base plate 1. So if you've been given connection details by your connection engineer or the main engineer and they've called that base plate 1, you call it base plate 1, because that will show on your GA drawings. Now in 2020, once you've got your connection vault, we could use the joint copy or the joint copy multiple, create a joint in a joint group, create a joint in a joint group multiple. But in 2020, you can select a joint, and we now have the option to propagate a joint, and that will search the model for columns of the same section size, and if it finds a column of the same section size, it will apply the same base plate joint to it. And those are all linked, so they're all BP1, and you can see that everything is grayed out. So I can't actually change any of those. They are all linked together. So I'm then putting a connection between the column the column flange and the beam. I do have a library entry already set up. So it's coming in at the predefined configuration. So you can see I have a library entry set up in there. So I can then propagate this connection. The only thing you need to be careful of, that will only propagate it to the column flanges. When you're using this propagate, just be careful with connections that have like a double-sided end plate or a double-sided purling connection. It will try and put the connection on a couple of times, or if you've got a single purling connection and you've got somewhere where you want a double purling connection, if you propagate the single purling connection, it will put 2 of those where you wanted to put the double. So you can control, the propagate will only work on items that the system can see on the screen. So if you turn items off within the model, it won't propagate onto those items. So moving on, we're going to look at the Graitec Advanced Steel Power Pack and the cover tools. So in the 2020 version of the Power Pack, all the connections now have their own tool palette. When you're using these cover tools, the one thing you need to make sure is you have your UCS set to the correct height. The covers, so the flooring cover, can be based on beams, or you can draw a cladding area. And you can put contours on the edge. So say you had balustrade posts at fixed centers, you could actually auto notch the gratings around that. And within the 2020 Power Pack, we can now add bolts. So we're going to go back to the model where I finished putting the connections on. And we're then going to look at using those cover tools. So the Power Pack, you get a new tab on your ribbon, and you can see the power pack connection vault there. You get a palette just like the normal connection vault. And we have a tab for the platform cover, the floor cover, and the borders, which is what we're going to look at. So the first thing I need to do is make sure my UCS is at the level that I'm covering. And we're going to start with the platform cover. So the platform cover is based on an area or beams, so I'm going to choose beams. So what you're choosing now is the beams that define the outside shape of your platform. So this little platform I've got here is as if we've got a piece of machinery sat in the middle, so I just want to cover around it. Once you've chosen your beams, you need to choose a center point or a point that is inside the cover, and then it's asking, do you want to split this up? So we'll say yes, and we're going to split it up based on all the support beams. So everywhere that there's a support beam, there will be a separate piece of cover, and then we'll let the macro create what it needs to create. So that will then create those individual covers based on what we've selected, and that is dynamic. So what we're going to do here is we're just going to select one of those beams and we're going to move it, and the connection vault will update itself. Sorry, not the connection vault, the cover tool will update itself and it will move that cover automatically. So we'll go back to that cover and show you what we can do within that. So we're going to make the covers from Graitings. So that would be your Redmond Fisher, your open mesh flooring. And then we've got the options in here. So the projection number 1 is from the system line of the beam, how far is that cover projecting? And then the gap between the covers is obviously the gap where the covers are split. So I'm going to, in a little bit, put some 5mm flat bars around the edge of these covers. So I want a 3mm gap between them, so that's why I've set the gap to 13mm. Now this is if we were doing it out of the Redmond Fisher. So this is where we can put standard edges onto them. We can put, if we know we've got pipes or something going through the middle of the cover, you can toggle between all the covers. The 2020 version of the Power Pack, we can now actually bolt these covers straight to the beam. So what we're going to do, we're going to change the covers to checker plate. So rather than modeling them as plate, we'll model them as a grating element, and that will put the hatch, the Durbar or the diamond plate hatch pattern on for us. So we're then going to say we want to use 12mm countersunk screws. Then we're going to go to the bolt distances tab, and it's the number of bolts across the edge of the plate. So if we say we want 1 edge of bolts, in every panel that will put an edge of bolts. Then we can set the edge distances. So because I'm using 75 PFCs, I want the holes in the center. That will then, as you can see, give me bolts on every panel. Now, they are the same for every panel because we've got that little tick box ticked. So if I untick that, it will then highlight the cover that you're working on. And we can say, right, this cover number 1, I don't want the same pattern around every edge. And then you can toggle along the 4 edges, and you could have more bolts, less bolts, different spacings, turn bolts off if you needed to put them in manually. So that's saying for cover number 1, edge number 1, I don't want any bolts on there. So we're actually going to just turn all of these off and set the cover back to the Redmond Fisher, because in another video in a minute we're going to show you how we can automatically put edging round all of these panels. So we want to put kick flats around these gratings. So again, there is a tool within the Power Pack to do that. So you select your grating, and that will put plates around the edge, around every edge of that grating. So what we're going to say is that the outside profile currently is made from plates. But what we're going to do is we're going to do these from and we're going to leave it on plates. We can then change the thickness. So my flooring is 30mm thick. So I've now put a 5x30 plate around every edge. Similar to the bolting option, we can say it's different on particular edges. So on the outer edge, I actually want a bigger kick flat. So I want a 100x5 plate. So you can see that when we say same for all and we untick it, we can then toggle to that edge and have a different plate. Now at the moment those plates are mitered. So again, we don't want that. We want them to be overlapping so that you've just got one plate running into the other. And now we can actually control which plate is taking priority. So again, I'm making all corners not identical. And then you can reverse the overlapping. So that in this one, it's the outside binding bars are the one, so they're fixed at the same length, so that we don't have lots of different configurations and plate lengths. And obviously on the outside, we want the 100 plate to be taking preference, so that it's running right to the edge. If you had holes in your covers, it would also do that for you. Now, because this is a joint, we can use the normal joint copy tool. So we can select our gratings. So I'm copying them around all of the gratings. I obviously need to go back and change the corner ones. So I'm just putting it on one corner at the moment. And then I'm going to go into that corner and choose Advanced Joint Properties. Then we just need to go to a different index. So you'll see that it's the plate that turns blue is the index. We can change that one to 100mm. And then now that we've corrected that joint, we can copy that edging around to the other covers. Now that end one is slightly different again, so we're just going to tweak that end one. And we'll change number 3 back to 30mm. So that is the platform cover. That will also weld the plates to the durbar for you. The next bit we're going to look at is we're going to look at the floor cover tool. So it's slightly different to the platform cover. The floor cover tool, you set the sizes that you want. So if you know you can only buy your durbar or your grating panels in 2x1 meter sheets, you can set that and it will tell you how many sheets you need to buy. So the outside is based on beams. So again, we can choose the beam option to drive this macro. So this time I'm actually going to cover the whole tool, the whole platform. Again, you need to give the system a point inside the cover. Do I want a reference? So a reference would drive where those flooring covers are being set out from. So what this will do is it will do panels of fixed sizes to cover the entire platform. So it uses standard grating, but I'm going to change it to variable grating in a second. So you can see that the standard grating is 6 by 1 meter sheets. But if my supplier has got some stock that they want to get rid of, or we've got some stock that we want to use, we can say that the panels must be 2 meters by 700. And then the system will cover all those outside beams with 2 by 700 meter sheets and nothing bigger than that. So you've got the two flooring options. You can say it was a bit of balcony or something that we were doing with timber sections. There are timber sections in advanced steel. So we could then do a balcony covered in timber cladding. And then you would know how many lengths of 2500 bits of boarding you need, and then it would put those in for you. So within the power pack, you've got a couple of different tools for very quickly covering platforms and also to put the kick flats on the edge. So the final bit of this webinar, we're also just going to show you the stairs and railings BIM designer. So again, it's another plugin from Graitec. So we can now do multiple flights and landing configurations all within the same macro. Stringers can be made from plate elements. We can do ball post, key clamp, and infill panel railings. We don't need, well, railings can be created on beams, lines, or points, but we don't need a beam in for it to work. And again, railings can connect to beams, plates, slabs, or actually we can connect to nothing at all. The post positions can be set by the user. And then special parts, we can manage these special parts. So we're just going to look at some of the things that we can do with that BIM designer. So similar to the power pack, when you install the stairs and railings BIM designer, you get a new tab. So what I'm doing before we go into that is I've got my construction drawn. So whether you're using the Graitec macro or you're using the normal advanced steel stair macro, you always need your construction for the staircase drawn in. So the stairs and railings BIM designer has its own tab on your ribbon. So we've got single flight staircases with just a single flight, or we've got one with a mid landing. We can do 2 flights in a right angle U or Z shape, and then again 3 flights in a U or a Z shape. We do have balance stairs that probably in the UK we would refer to as kite winder stairs. So again, we've got 1, 2 and 3 flight configuration. So we're going to use the 2 flight with a quarter landing at right angle. So you can see the construction points and the points that our Graitec macro require. So that's why I've drawn out these lines effectively at my finished floor level. So I choose my first point. It's then asking me for the turning point in the XY. Then it's asking for the end of the staircase. And then it's asking for the overall height. Similar to the Autodesk macro, we then need to control whether the stair is done to the left, right, or center of the lines. And that will then put in a 2 flight staircase with a quarter landing. So what we want to set, the most important bit are your flight widths. So we've got a dialog for each flight. We want to get all of this information set correctly before we go any further. And this is why I've drawn out my my staircase. I know how long those landing lengths need to be, and this is how our macro works. You type in the value that you want for those landing extensions, and then the rest of the staircase will drop in based on the rise and going, but you need to set your widths and these landing extensions first. So although it doesn't look right to begin with, we're going to go to the ergonomics tab. And again, it's using the rise and going based on a formula of 2 rises plus a going to give you the stride. But we can override this, so I can set the number of treads in each flight. And then once you've got the correct number of treads into each flight, it will fall into line, as you'll see in a second, with all my setting out. So by using the width, the landing extensions, and the treads that we need in each flight, that staircase macro will then fall in line with my setting out. So that's why it's important on any staircase you draw in Advanced Steel, drawing your setting out points and your rise and your goings, and you can check that what the system is modeling will follow what you want. So we can set then the minimum rise or the maximum rise, and the same with the goings and the strides. We get a protractor to say where our staircase falls. So these are just general angles. There's no hard and fast rules. None of these, no stair macro follows any standards, because these macros can be used in any country and every country has their own standards. So it is down to you as the detailer to make sure you're setting the correct rise and going. And then you get a graph to see where your staircase falls within the information that you've inserted. Then we're going to look at the tread types. So I want a a open mesh floor tread to match the flooring that we have on our platform. And then again, we're going to set it to the Redmond Fisher just to match what we've got on the actual platform. And then we're going to look at how these treads are connected. So at the moment, they are fully welded to everything. So we want an end plate on the tread, and we want that end plate bolted to the stringer. So we choose the options from the drop down. Can't quite see it because the dimensions aren't following what we need. So then we just work through the dialog and we start changing the values and the information we need. So we're just going to bolt these through with XOXs, and then we'll set the distances. In the rear option, we've got the option, well, we put a slot in there. So that will then bolt those treads to the stringers. Now, these stringers have been made from plates, and we do have the option for what I would call a mortise and tenon joint. The system is calling a miter cut. So if we don't want that connection, we're going to say, right, all these stringers are identical. And then what we're going to do is we're going to make the first profile a priority. So the stringer from the bottom flight will come up and the stringer from the second flight is going to butt into it. And that will do the same on the inside because we've ticked that everything is identical. So like I said, the stringers in this macro, that is one plate at the moment. So we can make staircases using plate elements. If you wanted it, we can still do it from profile, so we can still do it from flat bar. But one of the key features of the Graitec Stairs and Railings BIM Designer is that we can create staircases made from plates, and then we can start driving the macro with the values in the dialog. So at the bottom, we've got the features. Again, I'm just going to say they're all identical. And at the bottom, if you want a vertical section, we just choose that option, and then that will create a vertical section. And then what it's doing is it's putting the mitre in. So at the moment, they're two separate plates. But if you did want them as one big plate, we'll just untick that option. And that will actually merge those two plates together. The last little bit we've got to do is we need a short straight landing at the top of that staircase. So we go to the landing tab, go to top, and we'll say, right, enable a landing at the top. Now we do have the options to have a landing that goes to the left, to the right, but we just want a straight one. And then we've got the values in the dialog that we need to play with. So that will give me my two-flight staircase made from plate stringers with gratings, all within the one macro. So next we're going to start looking at the railing part of the Stairs and Railings BIM Designer. And we're going to start with ball post. Well, we're going through all the different types. We've got ball post, key clamp, standard railing, wall mounted, and then if you've got balustrade panels, we do have a little macro that will just put a connection between the two of them. So we're going to start with the key clamp macro. So with the Graitec macro, your input type can be beams, AutoCAD lines, or just points that you draw. So you don't need an advanced steel beam. Although on this platform, we are going to obviously bolt to the side of a platform, and we choose our start point and we choose our end point. Do you want to provide both post base points? I'm going to say no. And do you want to provide a nosing point? So this will actually model a railing system, but it will model a key clamp railing system. So what it's doing is it's modeling the rails and it's putting the key clamp components in as special parts. So I do have a library entry already set up for side mount. And that will mount that balustrade to the side of the platform, again with a key clamp fixing bolted into the beam. So that's all set up. In there, if you have a different supplier for your key clamp, maybe you buy interclamp or tube clamp, we can then add those into the system. So at the moment, I'm bolting to the side with a special part. These have been set up, but if you have a different supplier, you can add your own supplier in via the special part manager. So the special part manager there will allow you to create your own library of key clamp components. So I can add my own producer, my own supplier into the system. Then within there, you can start adding your own components, giving them names, and then they are just advanced steel special parts. So they're just 3D solid models that you can add into the system. So next we're just going to go to a 2D wireframe. We're going to look at the ball post macro. So I'm going to do this based on points that I just draw in. So rather than having a beam, I'm going to click the points that I want the macro to work on. So I choose my start point, and then we just draw the points that we want our railing to jump to. Then we choose the object we're going to connect to. So I can choose beam, plates, or grating. So this will now bolt through that plate. And again, do I want to provide base points? I'm just going to say no at the moment. And that will put in the ball post macros. So again, using library entries means I don't have to go through and set everything up. So the posts, we do have catalog posts from Linewell Kennedy. We do have a couple of suppliers in there. If you don't want to use one of those suppliers, what we can do is we can untick the use catalog post option, and that will allow us to define our own post. So then we can go to the post connection. Sorry, we can go in there. We can choose the balls. Again, the balls can be controlled by the special part manager. You can choose the post size. So I'm just going to use that library entry. And then you can see that that is side mount with a triangular plate. So that component there is a bought-in component. So it wouldn't run fabrication details for that. It would show up on your list as a bought-in item. We can get the system to run drawings for special parts. So we're just going to look at the final bit. We're going to look at two of the standard railing options. So again, do you want to provide both post base points? I've said no. So this is a standard railing. So we can set the post. We do have the option to do double posts. So if you've got flat bar panels, so we're going to look at a double post side mounted. So in any, even if you're not using the Graitec stairs and railings macro, I would always use, if you guys have standard staircases, standard railing configurations, set them up within the macro and then save them into the library, because then you can use these library entries as starting points. And that will give me the double post configuration with spacing, with plates in between separating them, so those panels are welded panels. And then the last little bit of railing we're going to put, again, is a standard railing. So the Graitec Stairs and Railings BIM Designer will actually allow you to model glass balustrade. So it's done through the standard railing macro. This time, when it says, do you want to provide post base points, I'm going to say yes, because sometimes you might have random post centers. So this macro will allow you to click the random centers, and it will model the post position at those random centers. So they are not fixed centers. And what we're going to do, we're going to go to the fillings tab. I'm going to enable the fillings. So that would be those infill bars. But what we're actually going to do is we're going to change those to panels. But I'm just going to load in a library entry, because it has it all predefined and preset up for me. So instead of fillings, that library entry is using panels. So it will model the glass connector for you, and it will also model the plate. And then what we can do with a plate is we can just change the material of the plates to glass, so that they get called up as glass panels. So I've enabled the panels. They're made from a plate at the moment, but we could make them from gratings if we wanted to. So those are just some of the things that we can do with the Stairs and Railings BIM Designer. That is the end of today's webinar. I will keep the session running for a few minutes if anyone does have any questions. But hopefully you have found today's session useful. Okay, I don't see any questions popping up, but in the handout you do have all of my contact details. So if you do have any questions or you want to discuss anything, please just reach out to me, and we look forward to seeing you on the next webinar. Thanks a lot.